In this country, bonds usually pay coupons semi-annually, so 2 coupons every year, one after the first 6 months and the second one after the second 6 months. Let's do an example. Let's say we have Quantum of Solace Corporation, another one of James Bond's movies, is raising money for new investments by issuing corporate bonds. The bonds have the following characteristics: 10 years to maturity, 8% yield to maturity, 12% coupon rate, and coupons are paid semi-annually. Same question as in the previous problems. How much can this corporation raise with each bond? In other words, we are asked to calculate the bond value. We have a 12% coupon rate, so as always, we can multiply it by a $1,000 face value, which will give us $120 in annual coupon. Except because our coupons are now semi-annual, we get half of that every half a year. So every half a year, whoever buys such bond will receive a $60 coupon. We have 10 years left to maturity, which means there will be a total of 10 times 2 or 20 coupons paid between now and the maturity date. And this is what we will use for N in the financial calculator. Because remember, in the financial calculator, N refers to how many recurrent payments we will have. Our recurrent payment is $60 repeated over and over every half a year. And we need to use N that reflects how many of those we are going to have. And to be consistent, everything throughout our calculations of the bond value should reflect this semi-annual frequency. So for the IY, the interest rate, the yield to maturity, we need to use this semi-annual interest rate. If per year it's 8%, which is given, then we need to divide it by 2. And 4% is the correct discount rate that we will use. So plugging these numbers into the bond present value formula will give us the bond value of $1,271.80. This is a premium bond because it costs more than $1,000. And of course, you can do it in the financial calculator. So let's do it together. Let's clear everything we had from our earlier calculations. Let's also increase the decimal places. Let's try second decimal place. Let's make it 6. Enter. Let's begin. So in no particular order, we need to enter the future value or the $1,000 face value, PMT, the dollar amount of each coupon payment, the number of coupon payments, N, and the discount rate or the yield to maturity, IY. So let's start with the face value. 1,000, we are making it negative, right? Press the plus minus button and save it as FV. The same sign should be used for the coupon payment. What is our coupon payment? Every half a year it's $60. So you put 60, you change the sign to negative by pressing the plus minus key, and then you save it as your PMT. Then how many of those recurring coupons will there be? A total of 20 coupons. You use that for N, 20 N. And the fourth number that is entered is the discount rate. It should also reflect the same semi-annual frequency, 4% yield to maturity per half a year. So I put 4 IY, and I'm computing present value, $1,271 and about 80.5 cents. So technically, if it's rounded to 2 decimal places, then that would be 81. If it's rounded to one decimal place, like on my slide, it's just 0.8 at the end of the answer. So keep consistency. If you have semi-annual coupons, you need to adjust kind of three things. The coupon is the annual coupon divided by 2. The number of coupons, number of years left to maturity, multiplied by 2. And the discount rate, it's the annual yield to maturity divided by 2. These three things, all three must be made in order to do the calculations correctly.